This is part 2 of Learning Target 5, where I can transform my quadratic from standard to vertex form. And here we're going to use completing the square to solve. So this is the first motivation and why we want to complete the square. It is a helpful way to solve a quadratic. So I'm going to look at 3 examples and of why we want to complete the square. So notice in the first example, the quantity x minus 4 squared equals 16. I want to show that this is a really easy quadratic to solve because it's already in the binomial squared form. And so in order to solve it, we're going to use inverse operations. To undo squaring, we take the square root of both sides. And so if you remember, this will give us the absolute value of x minus 4 equals the square root of 16 is 4. And so to solve this absolute value equation, we get x minus 4 equals plus or minus 4. And so x equals 4 plus or minus 4 by adding 4 to both sides. And so I will get x equals 8 or x will equal 0. So notice this step here, you can skip this step if you remember that you're always going to get the plus or minus on the right hand side here. So what we can see is when it's in this form, all I have to do is take the square root of both sides to solve. And so we're going to force that in these 2 equations. And so in example 2, we have x squared minus 2x equals 24. I'm going to complete the square on the left hand side. X squared minus 2x, well, what would I need to add to it to complete the square? Well, I'm going to cut negative 2 in half, which is negative 1, and square it, which is 1. So I added 1 to that side, which means I must add 1 to this side, so I get 25. Because it's an equation, we have to keep it balanced. Factoring, this becomes x minus 1 squared equals 25. I can take the square root of both sides, and I'm going to skip the absolute value step. So when I take the square root of both sides, I get plus or minus 5. So x will equal 1 plus or minus 5. X equals 6 or negative 4. Those are my 2 solutions for x squared minus 2x equals 24. Finally, more complicated one, but the process is the same. 3x squared minus 6x equals negative 21. Again, I'm going to complete the square. Notice, completing the square is easiest when a is 1, so I'm going to divide each term by a. X squared minus 2x equals negative 7. Completing the square, x squared minus 2x, divide by 2 and square it, add 1 equals negative 6, because if I added 1 to this side, I have to add 1 to the right hand side. This is now our perfect square trinomial, which factors to x minus 1 squared equals negative 6. Now I can take the square root of both sides. X minus 1 equals the square root of negative 6. X minus 1, forgot the plus or minus. X minus 1 equals plus or minus the square root of 6i. And so x equals 1 plus or minus the square root of 6i. So that's motivation 1 for using completing the square. It's a way to solve a quadratic without needing to use the quadratic formula.